Hi, you guys. Welcome to Audrey's Reading Area on this, yes, educational, terrific Tuesday. All right. And a big shout out to my grandbabies, Korea, Sanaha, David the Third, and Caden. Love you all. I miss you all. So, Alexa, what time is Audrey's Reading Area?
Audrey reads in her area live at 5, and please
Live.
subscribe.
Live at 5. Please subscribe. Live. Live at 5. Won't you subscribe to Audrey's Reading Area on YouTube? Please do. I need to change the name of this channel to Grammy's Reading Area, right? Grammy's Reading Area. That sounds kind of good because I'm Grammy to them. All right, you guys, Educational Tuesday. Don't forget to click like and share my videos either. All right. Educational Tuesday. I got an interesting book I'm going to read to you. Be a scientist. Be a geologist. Be a geologist. It's by Ryan Nagelhout, and it is a scholastic book. Be a scientist. So, I don't have my glasses. I thought I had my glasses. Let me see if I can read it without my glasses. I'm going to have to, right? Be a geologist. So, what is a geologist, you ask? What is a geologist? You see that? See that picture? That's why I have my rocks here. So, geologists are scientists who study Earth. There's a lot to study. Geologists focus on Earth's rocks. Earth's rocks. See that? So geologists focus on Earth's rocks, minerals, and other matter and the processes that they undergo. How the planet was formed and what makes it change are two other important topics geologists study. In a way, geologists are Earth's historians, right? They learn about the history of the planet or the events that made it the way it is today. You might wonder why that's important. Knowledge of the past helps geologists make predictions about the future of our world. You know what predictions are? Predictions are, if I say I predict something about the future, you're trying to say that something in the future might happen. Okay? In the future of our world. Do you have what it takes to be a geologist? Read on to find out. Let's see. It says the word geology comes from the Latin word geologia, which means the study of Earth. So the father of geology. So I'm going to read this part first. Informitarianism. Informitarianism. I hope I'm pronouncing that correctly. Hutton's most famous theory is the theory of is it uniform? Okay. Uniformitarianism. Uniformitarianism. I think I got it that time. So uniformitarianism. Okay. This states that Earth is being shaped by the same gradual process today as it always has been. These changes happen at the same slow rate as well. Before Hutton's theory, scientists believed quick, powerful events such as floods formed and changed the Earth. Okay? Though people have always been interested in how Earth works, the world's first modern geologist was James Hutton. He was born in Scotland in 1726. Though Hutton went to college to study chemistry and medicine, he became a farmer instead. Hutton became very interested in how weather changed his farmland year after year. Many people during Hutton's time thought Earth was only about 6,000 years old. Hutton came up with a theory that suggested that The planet was much older than that. He believed that rocks were continuously breaking down and forming new rocks over and over again. I mean, sounds like that could be true, right? Let's read on. Let me put on a pair of glasses. Let's see if I can see in these. Okay. Hutton thought changes on Earth were caused by heat coming from under the ground. Volcanic eruptions and other natural events, as well as formations like hot springs, proved this. The heat alters the world through chemical changes to rocks and the pushing and moving of Earth's outer layer or crust. It says these formations in Mammoth Hot Springs in Yellowstone National Park were created when water from the hot springs cooled and deposited calcium carbonate. That's interesting, right? That is so interesting.
Justin, he's
Interesting. So, igneous rocks. Igneous rocks. Geologists now know how rocks forms. There are three main types of rocks: igneous, sedimentary, and metamorphic. Each can change into the other two forms, depending on condition. This is the rock cycle. So this is volcanologists. Volcanologists are geologists who study volcanoes and the process that take place under Earth to make them erupt. They try to predict when volcanoes may erupt, which can save lives. Some volcanologists study underwater volcanoes too. Yeah, they study underwater volcanoes too. It's amazing. Wow. Since volcanic rock can be full of valuable minerals, some businesses are interested in hiring these geologists. Um, it says geologists called volcanologists may wear special suits and masks to protect themselves from the gases and hot ash that erupt from volcanoes. It says igneous rocks are formed from magma, the hot liquid rock deep inside Earth. Magma flows up through the cracks in the ground and it may get trapped in hollow pockets where it cools to become intrusive igneous rock. Geologists discover that slow cooling underground igneous rocks have big crystals, like those found in granite. If the magma reaches the surface, such as lava erupting from a volcano, it cools quickly to form extrusive igneous rock. Fast cooling lava produces rocks such as pumice, which is light and full of holes. And this says the speed at which magma cools often decides what kind of igneous rock is formed. How interesting is that? Sedimentary rocks. Igneous rocks can form quickly once a volcano erupts, but the other two types of rocks form more slowly. Sedimentary rocks are made of bit of rocks, sand, shells, and other matter that have been worn down by weathering. Weathering is a process in which water, ice, snow, and wind break down rocks into smaller pieces. I guess that means like the weather causes that. I'm just saying. Sounds like it to me, right? These bits may be carried by wind, water, or ice to another place where they settle. This is the process of erosion. Sediment, which is what the bits are called, collects and hardens into rock as a layer. Layers press down on other layers over time. They're easy to spot in exposed rock formations, such as cliffs. Cliffs. Rock weathering rocks. Rocks weathering rocks. So when wind picks up sand, it can travel great distances. Geologists discovered that the Grand Canyon was formed after millions of years of weathering, not only by water, but also by blowing sand. Wow. Layers of sand sediment called sandstone are still visible. By knowing how the rock cycle works, geologists have explained how many amazing landforms were created. Metamorphic rocks. Metamorphic rocks. The word metamorphism is Greek, is from Greek words meaning change of form. Metamorphic rocks were once sedimentary or igneous rocks, but changed form because of heat and pressure deep inside Earth. Extreme conditions result in rocks changing texture, appearance, and even chemical makeup. Metamorphic rocks often have ribbons or waves of minerals in different color because of different levels of heat and pressure applied to the rock over time. They have shiny crystals in them too. A movement of Earth's crust called uplift, as well as weathering and erosion, brings metamorphic rocks to the surface. Types of rocks. They have types of rocks: igneous, sedimentary, and metamorphic. How it's formed. Take a look. Features and examples. They have marble rocks are under metamorphic. I'm just saying. Our puzzling Earth. Besides uncovering the rock cycle, geologists have worked for centuries to unlock many of Earth's mysteries. They've discovered that Earth's outer layer works like a puzzle. It's made up of broken pieces or plates that slowly move. There are dozens of plates, and the major continents rest on the biggest plates. It says the theory of Earth's outer layer, consisting of many moving pieces, is called plate tectonics. Plate tectonics. Can you see? It says from a point above Earth, it's easy to see where two plates may be interacting to create landforms. Wow, look at that. That's interesting. Right? These tectonic plates move many different ways. They can grind past each other and cause earthquakes. Some push together to create mountains. They can move continents closer together or farther apart. By studying movements in the past, geologists can predict where the continents will move in the future. Wow. So seismology and, this is a hard word, paleoseismology. Look at that. It reads, some geologists focus on earthquakes. They're called seismologists. Paleoseismology is the study of prehistoric earthquakes. Wow. Didn't know that before. Paleoseismologists study the timing, location, and size of these earthquakes. They look for prehistoric faults or breaks in Earth's crusts. These may hold prehistoric rock and soil that can tell us what Earth was like thousands of years ago. Nice. I really like this picture of the Earth coming together, right? Or pulling apart, one of the two, right? So one career, many choices. So people interested in a career in geology need to be ready to study. At the very least, geologists attend college for 4 years. They major in geology, but also study math. I don't like math too much. Math, history, and many kinds of science. After they graduate, they may work for private businesses such as mining or energy companies. They may work for the government too. Many geologists choose to stay in school and earn a master's or doctoral degree. Then they can become teachers or do important research. They can also specialize in their studies to become paleoseismologists, volcanologists, mineralogists, and another kind of geologist. Start with soil. See what that says? Start with soil. Look at them. So even the dirt in your backyard is interesting to a geologist. Soil is made up of rocks and minerals ground into powder. These are also living in dead things in there. This is there are also living and dead things in there. All these offer plants a healthy place to grow. Because of geologists, we know it takes millions of years to make soil. Mm-hmm. Studying outside. Look at that. Studying outside. Many geologists choose to teach at colleges and universities. Part of the time, they instruct students in the classroom. However, they also take classes into the field to study different kinds of land formations, show proof of Earth's processes, and observe changing surroundings to learn about an area's geology history. Okay? Sometimes this means traveling to locations around the globe. Some schools ask geology teachers and students to research and publish their findings. There are many colleges all over the country that offer geology programs. If you're interested in geology, you should see one of these schools. You should see if one of these schools is near you. Really cool. So, glaciologists. Another form of geology doesn't focus on rocks at all. Glacial geology or glaciologists study ice, including snow, sea ice, glaciers, and ice streets. These examine how snow and ice affect Earth today, as well as how they affected it in the past. Glaciologists often work in places like Antarctica, Greenland, and the Arctic. Nice. Working in mining. Geologists who work for mining companies locate valuable minerals called ores in the ground and figure out the best way to remove them. Ores may be valuable themselves or valuable for what they contain, such as the element copper, silver, or gold. It can be costly to dig for one, so a geologist figures out the best areas to mine. Geologists also help make maps for constructing tunnels and plan methods for workers to remove ores, right? Rare earth elements are important today to mining companies and the geologists they employ. Much of the technology we use, such as televisions, cell phones, and computers, contain rare earth elements. Rare or not, rare earth elements such as cerium and scandium aren't actually rare. They're found all over the world, but they don't often collect in large amounts in one place. This makes geologists essential to mining companies. Without a geologist, companies wouldn't know where or how deep to dig or when to stop looking. Mm. Mm. Working with energy. Woohoo! Energy companies need geologists to locate fuel sources such as natural gas, coal, and oil. These form over millions of years as a result of great pressure on plant and animal remains buried deep within Earth. That's why they're called fossil fuels. The kind of fuel produced is decided by where the matter is forming underground, the temperature there, and the matter surrounding it. Geologists can find new sources of oil and gas by collecting and analyzing samples of rock and soil. Samples of rock. This is my second rock. Samples of rock and soil. Yes. Got my little rocks here. Samples of rocks and soil. So, if they're like samples found near known deposits of oil and gas, there may be a supply nearby. Geologists even analyze samples from the ocean floor. It says oil drilling. This is an oil drilling platform. They put the platform up and then they drill down to find oil. It says over here, I guess that's a picture of a real one, right? Geologists often find fossil fuels by searching for sedimentary layers that trap them. Geologists in space. They are everywhere. I love it. I love it. Geologists study Earth and all the materials and processes it contains. However, they can use this knowledge to learn about other planets and space objects too. Geologists who work for NASA, which is the National Aeronautics and Space Administration, they study moons, planets, and other space objects. After all, these are made of the same matter as Earth. So it says Harrison Smith. Harrison Smith was the 12th and last person to walk on the moon. He's also the only geologist to visit the moon. Schmidt worked for NASA and went to the moon with the Apollo 17 space mission, landing on December 11, 1972. He later served as a U.S. Senator. Harrison Smith spent 22 hours and 4 minutes on the moon's surface. Look at that. The Curiosity rover landed on Mars in 2012. It has many tools to help NASA geologists and other scientists explore Mars. Scientists are finding out a lot about Mars with the help of a machine called a rover. It travels on the planet's surface, takes photos, and collects rock samples. It can actually analyze the rocks too. Geologists now believe that Mars has plate tectonics just like Earth. You can be a geologist. You can be a geologist. Yes, you can. Being a geologist means you're never far from your work. The entire Earth is your science lab, and there's always something new to discover. But being a geologist is much more than the ground beneath you. Your studies can take you all over the world or into outer space. You don't have to wait until you're in college to learn about geology. Find out what rocks and minerals make up your city and your town. You can go to a local park or visit a museum. There may even be a geology or rock collecting club at your school. If there isn't, start one. Start one if you're interested. Over here it says, caves are another great place to study rock formations. Interesting. So we have a glossary of words. So you can read them and read the definition of what they are. And pause. Pause and read. Right? That is the end of this book. Wow, I had fun reading this to you guys. That was fun. I learned right along with you on Educational Tuesday, right? I learned just like you learned. And I'm thankful for it. I love to learn and I love to read. So thank you for being here. Thank you, Mom, for being here. My mom is here, y'all. Thank you for being here and always showing all this love and support. Well, you guys, I gotta go. So don't forget to click like and share my videos, and don't forget to go to Audrey's Reading Area on YouTube and smash that subscribe button for me. All right. See you tomorrow, right? Right here on Audrey's Reading Area.